Okay, hello everyone. Welcome back to Torching Complete. Um, just a few clarifications. Last stream I was extremely tired. I think I briefly mentioned that. So I wasn't super engaged in terms of dialogue on that stream. So yeah, I just want to say I'm feeling much better today. And as a result of that, I think that in the spirit of the stream, I want to complete the counting signals level in Minecraft. I was considering skipping this because of the complexity, but I decided I'm not going to because I decided at the beginning I would build every level, and if we skip one, who's to know how many more we will skip. It'll become infinitely more tempting if we give in here. This is a really complex one, just in terms of, it's not like complex conceptually, but in terms of implementation, it's a bit of a pain. I think that's a better way of saying it. So let's go check this out. So we go into the campaign, we go back to the completed counting signals episode. I've already sort of separated, but here was my first solution. So, yeah, I mean, there's not much to say about that. I think that's pretty self-explanatory. We're gonna redo this. I went ahead and copied the original solution. As you can see, the input and the signal counter are separated from but the signal counter goes here, the inputs go here. We're gonna make a new one, and we're gonna make this based off of something I saw online. It's using buses, or just using common wires, which will make a little more sense. I'm having a hard time explaining that right now, but that'll make a little more sense as we continue. I guess a good way to illustrate is every single gate here is uniquely connected to the input, and it doesn't have to be because a lot of them share signals. So if we can condense that, I think we can get rid of a couple of these gates at least, and definitely clean up the wiring so it actually looks comprehensible. So yeah, let's get started. We're going to start with a revolutionary change here. I realized that you can change the wire color, and I honestly think that's going to be pretty big. Oh, what is this? The multicolor? I don't know. We're going to go with solid colors and not try to guess what that is. Looks like there's gray. Okay, so I say we just sort of go in order. That's one's not selectable, so that's the current color. So we're going to do gray for the first bus, yellow for the second. Looks like that's sort of like an orange and a red. Admittedly, I do have, I'm going to actually turn that off for just a second. I have red shift on, so I can't see. Okay, it looks like it's orange and purple, or a pink maybe. So yeah, I think that's perfectly fine. They're not exactly like visually pleasing, but they are respective to their order. So the first bus, second bus, third bus. So I think it'll make a lot more sense. Oh, gosh, but these colors are really pretty though. I mean, maybe we do make something a little more cohesive in terms of coloring. I wish we could do a gradient. So now that I have this off, what is this? It still looks like one color. I'm not getting the half and half here. What if we did? I think white's okay. White, pink, blue, and yellow. Let's try it. White. But orange is good too. White, orange, pink, magenta. That's really just skipping over the gray wire and starting it from here. So it does make sense. It still looks ugly though. Love the blue. Not as big on that blue. Turquoise and green. So let's go with the sensible colors, I guess. Or you know what we could do? I could be a bit of a gradient. So we could do this like green, followed up with turquoise. And then I would say blue and then purple. You know, they all don't look that amazing. White and blue always go really well together. And then I would say white and orange go really well together. So that's, we're spending the first 10 minutes just getting a color code. And then let's try yellow. I mean, it's green. Nope. Gray. Gray seems like nothing burger color. Just not very fun. I mean, we have one more choice after, so I honestly think, yeah, okay. So this to me is like probably the best. Here's what we do. As we do, right? That makes sense visually. So I think we move that to the top as a legend, you know, for first. And then, okay, you could do comments. So let's do first bus. We're getting real, we're getting invested into Turing Complete here. So look at that. That actually doesn't look too bad. Second bus. Third bus. And fourth bus. Not bad, huh, guys? Cool. I think that'll work. That will work. I'm gonna go ahead and turn on my I'm tinting my display to a bit of a more red hue just so it doesn't hurt my eyes after long periods of time looking at it. I don't know if that's actual, you know, if that's tried and true, but it works for me. So anecdotally, it's great. But see, even with the night light, it's very difficult to see these colors properly because I have it on intense red, so the distinctions start to disappear. Okay, so that's yellow. I guess for this level, we'll turn off the night. Okay, let's keep going. You guys obviously can't see what I'm doing, so I'm just gonna check the stream as always. Yeah, looks like we're good. Moving on. So just to check the level log, the output component of this level is a binary counter where the first 3 pins correspond to 1, 2, and 4. Now that confused me, but that just means it adds 1, adds 2, and adds 4, right? I don't need the hint. The solution for this level is not very great. That's all it gives us. So we need to match the desired output with the current output, and that involves those inputs being green. So it's pretty straightforward. It's just overwhelming when you first look at it. So here was my idea. I saw a solution online for probably 0.2 seconds. I just glanced it, and I just like their use of buses. So the idea is, if that's first, right? Second, third, and fourth. And I number that not only in order, but based on what, well, yeah, that actually is. It just means the input. So I guess that's better titled input 1 bus, but I think we're okay for now. We can even title these input 1. I mean, what do you guys think? Yeah, I think that makes a little more sense. It's a little more consistent with the wordage. See, because it's more cohesive with the level. Great. So white is input 1. So it starts with everything off. That's right. So we have our desired output. Then we move 1 step, and we're wrong because this, which is on, needs to power the first one. So it's going to need to power multiple. So I think we're going to drop an XOR. There's going to be, yeah, let's do it for now. It's not going to be very clean, but let's continue. Let's actually establish these buses beyond, let's establish them vertically. Is it really interchanging that, like over under? Oh, I mean, maybe. Yeah, let's square these off. Right? Already, this is a lot more organized. It's not the prettiest thing in the world, but it makes, I mean, look where we're, like, this is just, that's an abomination. I mean, I shouldn't say abomination. It was my first try, I'm being a little hard on myself, but this is, this might be something to be proud of. So, okay. If we pull this, oh gosh, I hate how that goes over. We might need to restart these because that was terrible. So let's try pulling that out. Just as many on the other side. So we'll get this a bit. It's also so much easier with the color coding to see overlap too. Just like infinitely easier. So let's take this over. Much better. Look at that. And then we will connect that. Oh, the final connection. I say we do gray, right? Because sort of the unimportant, not unimportant, but I think you get what I mean, where it's whatever is connected to the input signal counter. So okay, that's powering in directions that don't feel very natural. But if we just ignore that, it's going straight to the XOR, which is going to power that. Why do I put an XOR there? Because multiple will need to connect to the same output, and if you do, if I did two inputs on the same output, that's a short circuit. Yeah, that's right. It's a short circuit. Okay. Cool. So if we move to the next step, that's wrong because this needs to also connect to 1. So this is going to illustrate the point immediately, is if we put input 2, that's going to need to also connect to the output. So they can share an XOR there. Which we're not exactly hyped about that layout, but it's okay. You know what we could do? Nope. Uh-oh, what happened here? Luckily, Control-Z saves the day because I couldn't even see that. That'll be fine for now. Whatever. Let's keep going. Okay. So now these both need to power, need to have an output of 2, and so we need to hit that second one because that'll output 2. So again, not just the order, but the value, 1, 2, and 4, remember. So second one does happen to output 2. They both happen to have the same number. So, okay, so we have an and they need to accept both inputs. We have there. We have there. See, that looks nice. I just don't know why we can't accomplish that. It's because there's a layover, I guess. Can these be reconnected in a way that makes sense? Can yellow go over? It seems to not like that. I don't know why, but I guess we're gonna accept it because I really just want to take this yellow from here, not there. I think you get what I mean. See, it's attaching to the orange, which is a bit frustrating. Wait, but why was it attaching to orange? That's the question. Why did I have that? Oh. That's why, because it was connected. It literally needs to connect to the output. And now I'm actually noticing that blue is not connected to anything. I don't know if I forgot that or not. I think I did. Okay. So, let's just trudge forward. Wow, that's not going to happen. Guys are definitely getting Turing Complete footage, no question. I think just for the sake of consistency, I know I'm prematurely optimizing, but we're going to put that up there and that here. So when we do use the gray, right, that makes sense. Okay, so let's start over. We have the white. We're going to connect that to the first XOR input. Oh my lord. Please no. Okay, here's what we're going to do. And I know it's annoying. We're restarting already. Here's what we're going to do. We need to center this. I just don't want to have to deal with that in the future. Be constantly rearranging this thing. Okay, we're going to center this. We'll drag this all the way up there. And we're going to redesign that later. We're going to separate it from the legend from 1 so it's still like visually nice. There. We're just going to really stretch these all the way up there and all the way up there. Okay. Then we're going to take the white all the way down here. All the way. All the way. Nope, that's connected to blue. What just happened? Oh, it's because there's this little connection here. Not great. All the way down here. And all the way down here. I mean, half the battle is just fighting with the Turing Complete mechanics. But, Now, what we're going to do is take this and drag it to the top. I think. And then, oh yeah, if we do it there, I think we just go down the line with the gates. This might be the start of something. But see, actually, no, I spoke too soon because it needs to be one down, because then you're going to get those collisions that I literally just tried to avoid. So here we go. I think I remember that yellow was on there, and then you had both connected to this and. Does this make sense? Okay. Right, so let's try it. Good, good, and good. Great, so we're getting somewhere. And we have good there too. So that looks nice, better, comprehensible. If you went through each step, you could get a good idea of what's going on here. Especially with the color coding. Gotta love the color coding. Okay, so now we have another one here. Here's where it gets funky. So now we could just nuke the grays. That needs a new XOR. So what we're gonna do, pull this over, and we're gonna put an XOR right in front of it. Nope, right below it. What if it was right in front? What if, right? Yeah, that breaks. So if I do this, still not good. Okay, new idea. Gosh, we're getting rid of more than I want. New idea. You know, it'd be fun using the same colors in Minecraft. It'd be also easier to build, but it kind of ruins my color coding in Minecraft. I guess I should have thought about that, but you know what? We're okay. So yellow is always second, so we're just going to put that on the second input. We want everything to be respective, you know? So great. That needs to be on the XOR, so we throw an orange there. Oh, beautiful. Looks great. Okay. So that back, let's get our grays, our temps, right? Boom and boom. How's that? Oh, we made a mistake somewhere. One, that's not good. So what's wrong here? Those, oh, I see. Sure, you can also see what's wrong there. Connected it to yellow. It needs to be white. Isn't that lovely? Isn't that lovely, guys? Let's keep going. Now it's 1 and 3. So we're going to need an and. Another and. So if we throw an and here, we're going to separate these by 1 unit. And let's get the white again. Oh, no, I don't want a wire comment. Excuse me. No. Oh, if you just click on a wire, it'll assume you want to comment. Okay. That also needs to connect to 2. So there needs to be an XOR, as far as I'm concerned, connecting these two ands. Am I right? So if we throw that here, which actually is kind of cleaner, but no, it's fine. Here, nuke the gray. Nuke the gray sounds like a Lord of the Rings wizard. Nuke the gray. Okay, so nice. That's already looking better. And you know, if it's not the ideal amount of gates and there's a better way to do this, I'm already so much happier with this. So now we need another and. Okay. So what do we have here? That's all right. Let's do and. I love this bus thing. This is fantastic. Okay. And see, you can't do this, right? Because that's a short circuit. So I think we have to just go with another XOR. That's at least my understanding. Why do we connect that? Okay, let's think about this. No, what you do is, take this out. It's getting harder to remember where these were put. Okay, so what we're doing, we're taking this XOR output. yeah, we're replacing it. XOR, and then we're going to connect that AND. Something's wrong again. Oh, right, because we didn't actually end up connecting this finally. Let me just check the chat real quick. Look good. Okay. Boy, I hope you guys can't hear that noise. Let's configure that. Or mute that tab. Cool. How far did we get? That looks about right, doesn't it? 1, 2, 3, 4, 5, 6, 7. Okay, someone said they made this in 9 gates, which is a bit compelling. I'd like to try. 1, 2, 3, 4, 5, 6, 7. Okay, here is where our unique one falls through. So, yeah, let's just make this look a little better. Or actually, that's kind of the best it'll look, at least for the time being. That's okay. Let's leave it. Getting distracted. Okay, blue needs to be connected to that. So, I'm thinking off the bat, you know, oh, that's the reason I made buses. Excuse me. I think that's the visually most pleasing version, right? It's just, I don't know. Yeah. Oh, yeah, because you don't want to have to deal with clicking the wrong one. I think that's okay. Right? Okay, now blue and white need to connect to 2. So what that means, somehow I feel that triple ANDs would come into play at some point. Okay. Blue and white need to connect to 2. It's asking for another XOR. You know, XORs are kind of a magical gate, aren't they? I wish we can connect that directly, but you know, that's the spirit. Another XOR. We're gonna put it down here. Okay. Oh, I'm sorry. Yeah, I mean, those are separate, so... Let's just go with that. I'm pretty sure someone used an OR gate on this one. Not an XOR, not just an XOR. I think we're already at 9. 1, 2, 3, 4, 5, 6. Yeah, we're at 10. I see. I'm curious how someone did this in 9 gates. It might be a bit troubling, but I think we complete it before asking those questions. Based on, like, you know, my unique design at least. Yeah, see, I knew something was wrong with that one. Let's go back. That's an AND, if I'm not mistaken. The every other is failing us at this point. A bit heartbreaking. But not if we sort of disobey the order. Okay, how? How exactly did that do a short circuit? One. So what's going on here? I'm kind of losing track. 1 and 4 need to output 2. Therefore, we need this. And then this. How exactly does that cause a short circuit? It doesn't now. So we need another XOR for 2. Okay. Ooh, in that case, should that be... nope, definitely not. All right, throw another and down. For 2 and 4. We don't have a triple XOR, do we? No, we don't. Yeah, there's no way to invert that to make that exclusive. All right, another one. We're chaining these ones pretty well, aren't we? Okay. 3 and 4. Back to the hands. Anything being powered? Yeah, 3 and 4. It just seems like there's a much more efficient way of doing this. That's just what I'm naturally getting here. And we're running out of room. Can you move this thing? Oh no, but not with the wires. Let's hope you could get this done. Now it's funky. That's on the 2, right? Where are we? So when they're all powered, what do we get? So wait, yellow and blue. So we need white and yellow on an and. There. And then orange and blue. There. It's like the first and the last. So if we do another and, we don't need another unique one. So we could just go get a little crazy. All right. Okay, so I mean that does it. It's definitely better than this, no question. I'm wondering how this could have been made shorter. You could have done something like this to chain those a little closer together. You know, you could even do that. It looks terrible. So you could just have them separate. You could do that, right? You can connect like this. But that also hurts like the openness of it. Chaining it downwards, I guess, is good because. Oh man, I'm still debating whether we build this. I think we do. I'm gonna quickly look at, because I think the original developers this was their solution. Yeah, okay, it was. So these buses like that, it's probably where I saw it too. I'm essentially looking at what we're looking at our screen now. So let's just count how many gates they're using. 1, 2, 3, 4. No, I'm sorry. 1, 2, 3, 4, 5, 6, 7. Nope. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They use 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the 16. This is 16 XORs and 16 ANDs. Let's go check out our XOR gate. I think it's pretty big. It's pretty big. Yeah, so this is just the inverted. Yeah, so that's our XOR. Our AND is remarkably small. So we also need a signal counter. That's the thing. Yeah, we'd have to build a signal counter. So that's like a whole nother thing, storing values in Minecraft. Like, we're kind of jumping the gun with memory. I feel like because if I'm not wrong, we have a hopper, right? We have a comparator. We have a string of redstone. Oh, it's not 1 to 1. So if I put in 1, I wish if I put in another, it would power the next one, but it doesn't. Okay, so non-stackable items do something different. So what happens if I put in another? Okay, we're getting somewhere. Let's try non-stackable, and maybe we just use like a barrel or something. So, okay. Right, check this out. That's 1. I'm hoping it goes by 3s. That's another 3, another 3, another 3. I mean, let's make this a little more clear, shall we? Okay. 1 signal, 2 signal, 3 signal, 4. Right? That's a signal counter. I mean, it's a pretty big one. I'm wondering how we could make this a little smaller. I don't see. This is where my knowledge of comparators starts to go down, because I know it subtracts from the side. Subtract one? It really doesn't help us. I don't get subtracting. Okay. Sure. So we should really be doing this with concrete. Wait, isn't there a replace function? Or is it just fill? Fill replace? I'm looking this up. Oh, okay, it is fill, and then you add the replace. Okay, so just for testing's sake. Boy, oh boy. Right. You all saw it yourself? So here's the idea. And you know what? There's so many better ways of doing this, I'm sure, but this is my way of doing it. And isn't there a little bit of, I don't know, freedom in that? Why isn't that powering? Is it because it's on a slab? Yeah, I think so. That's the kicker, because that's exactly 3. So I was hoping that would work. Oh, how about this? So that's 3. What I'm trying to do here, if you haven't gathered yet, is I'm trying to just condense these lines. Oh, but see, that can go up too. Not fun. Not fun. Not fun or clean. You could do it off to the side, but that's a bit boring. But I guess it works. So what the heck? Let's try it. Yeah, that kind of get, you know. That's okay. I think it does condense it though. Hey, now. Ooh. Well, technically we don't need the slabs anymore, do we? I just wanted to get a little clever with right? No, that's not what we want. 1, 2, 3. 2, 3. Yeah, that is 5 instead of 6, isn't it? Isn't Minecraft music just beautiful? Ugh. So pretty. It's definitely 3. 1, 2, 3. 5, 5, 6. I mean, does that actually reduce anything? Yeah, I mean, a little. You see why I wanted slabs? Okay. I think we're gonna have to split this problem into 2 episodes. Not saying that's, you know, that's just right now, but that's what I'm suspecting. Sure. Just wasn't exactly what we were looking for. Dust is just simply not a tileable thing, so 3, 1, 2, 4. That doesn't. Okay. That doesn't make a difference. Because now it's only one block apart. I think that stands up. Okay. Right? Great. So I'm sure that there are a lot of people who could watch this be like, wow, I can't believe he's not seeing the obvious solution here. Just to talk about that for a bit. So it's like, there's going to be a lot of people in life who are like, oh, like, you could have done this so much simpler, and how did you not know this design? First off, you have to start somewhere. So if you're doing something and you make it work, congrats. A lot of people don't have the initiative to do that. So that's enough to be proud of, even if it's a bit of a spaghetti monster. But then after that, someone could be like, oh, this could be optimized. It could be so much better. I think the optimal response is, in a loving fashion, why don't you do it, right? Because a lot of the people who will say that are the people who don't really have the initiative to do so themselves. And if they did have a solution, it's probably something they learned they didn't make. Because, you know, you have pretty lauded people who have created the most optimal solutions and have published those papers and stuff, but a lot of the time they're just regurgitating that. And sort of like, so how did you, so it's basically a judgment on ignorance. It's like, how were you ignorant of that solution? Well, I mean, you know, sure, you should be striving for excellence, but you have to start somewhere. So that's just, you know, lesson of the day. Now, see, love that I say that, and then the third non-stackable item it powers. I should explain. Okay, in a hopper, so one of the main functionalities of a comparator is it can output a redstone signal strength based on how many items are in a hopper. So this is different for stackable items versus non-stackable. For stackable, it's you need to, I think it's like 13, every 13 blocks are in there. Could be wrong. You can check that. But for non-stackable, like iron chest plates, meaning I can't put them on top of each other, I can't put them in a pile. They induce a greater signal strength. So let's see what's going on here. So it's a strength of 3 for, you know, so let's see here. 1, 2, 3. That's right. It'll power the first one. Then if we have 2 in there, it does a signal strength of 6. So 1, 2, 3, 4, 5. 2, 3, 4, 5. Now that's literally what I was trying to avoid with the other one. So the idea then, take it out one more, and that's the obvious solution. Am I right? Okay. Doesn't look gorgeous, but is that one too many now? It is. I actually added 2. That's really funny. So that would be this. I believe that's 6 now. So 1, 2, 3, 4, 4. Or sorry, 1, 2, 3, 4, 5, 6. Okay. And then I'm assuming for the third one, 1, 2, 3, 4, 5, 6, 7. But now you have to add 2. This is not a very good solution. It's very ironic after that little discussion, but let's strive for something greater. Is there anything that could assist us? Not that is immediately obvious to me. This is all for something that might not even work. I mean, a signal counters and how many are on? Oh, you know what'd be fun? No, that's not gonna work. Not gonna work at all. So just reduce the design. One, two, three. This is how we started, right? Okay. 1. No, can't tile them. So do you go down at that point then? Do you go down? Here's the idea. One, two, three, four. Ah, that is just so very frustrating. Maybe we take it from the top, right? Instead of starting anew for consistency. So let's say that's 3, right? Then we take from 4. 4, 5, 6, right? 1, 1, 2, 3, 4, 5, 6. Or that's a big design. I mean, yeah, sure, that works, but and even barely at that rate. It's 3, and then let's just say, see, not exactly, so it didn't work. 4, yeah. I mean, at this point, why not just do like a line? Right? And then so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I was trying to do the slabs to try to like extend it or just like or reduce it, but I mean I mean that's a design, so. No, because we're taken from the original signal again. So it actually makes sense. There's a bit of a zigzag. Okay. Ugh. Sure, it works great, but looks disgusting. Not disgusting. You can't use that kind of language. Okay. I just wish it didn't give out 3. How do you convert 3 to 1? How do I convert a signal strength of 3 to a signal strength of 1? How is that done? Dare I say another comparator? Now I want to figure out how this subtract thing works. Okay, that's the cleanest solution if this just fails. So how do I convert a signal strength of 3 to a signal strength of 1? And that would go infinitely as far as I'm concerned. So that's got to be best. Okay. What if I have that there, right? What does that do? We want it to still power, but with the minimum required. Let's do a little experimenting. We're learning how a comparator works. Does that do it? Yeah, you drop 2. So if we put it in subtract mode, I mean, what's going on here, right? I thought that inverted it. Whatever. Okay, so that signal strength it's a bit silly, isn't it? That converts 3 to 1 as far as I'm concerned. Because if we powered it just a little more, we're subtracting 2. That doesn't work. Great, so how do we replicate that at a smaller scale? Another search. A redstone comparator in subtract mode outputs a signal strength equal to the rear input minus the highest side input. Equal to the rear 3 No, it doesn't. Because that should power, am I right? I'm doing a little, I'm just going to clarify. If the back input is higher in subtraction mode, the signal that goes through is the strength of the back minus the side. If it's higher. The strength of the back minus the side. So if we have the strength of 3 minus the side, which would be 1, no, 2. It makes no sense why that doesn't work. Because that is the strength of 3. And then the signal dies here, right? It certainly does. It is outputting a signal strength of 3. We've confirmed that. Now, some sort of texture packer mod would really help that would illustrate these numbers. Strength of 3. Okay, it's strength of 3. If it's higher, oh, but so that just functions the same then, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. When the redstone signal, say you've got a strength of 6 coming into the side. How is that not powered, guys? Now it's powered? Still powered? Still powered even yet. But that's dead. This is unbelievable. I think we're getting a little out of hand. We're already almost to an hour and I haven't even started the signal. So, I mean, to be fair, I created the, recreated this thing, but this comparator thing is really getting me. So in subtraction mode, which is this mode, if the strength of the back is 3 right now, or 2. No, because let's try this. Let's see, let's compare, pun intended. That's a strength of 3. Okay. Which is powered. How do you emit a smaller signal in a short amount of time? Do you just use a barrel and then yet another comparator? I mean, see, that's crazy. This seems a little crazy. It takes 1? Sorry, we're in subtract. What is that signal strength? Is it literally 1? That's a signal strength of 1. So it's receiving 1. And the back is 3. 3 minus 1 is 2. So why isn't this powering? Am I crazy? What will make that power? What makes the subtraction power? What? Simply what? Like, how many of these? What kind of strength does it need? I mean, what is that strength like? Right now, what is this strength? That should be completely unnecessary. Subtract mode is really getting me right now. I guess we might be losing track. I'm going to watch a little video on this. Oh, you guys hear desktop audio, don't you? That's big. Right, because why wouldn't you? Okay, here's what I'm going to do. I'm going to stop the stream here. Thank you for getting this long, getting here if you did, sticking around. I'm going to stop the video here. I'm going to make a signal counter in the back. I don't think I'm going to stream that because I don't think that's an essential part. It's more concerned with redstone than it is with the actual level. We are dedicating to building the logic of the level, not necessarily, you know, the logic of the components that are required in order to complete level. I'm going to stop the stream here. I'm going to figure out this comparator thing. I'm going to make a signal counter, and then I'm going to explain it in the next episode. How I did it, how it works. Okay? I think that's a deal. Thank you guys for watching. As always, I appreciate it. Hope you have a wonderful day, and take care. God bless. Bye.